Greetings. Thank you very much for the time you've given us to report a project about the ASHRAE Competition Integrated Sustainable Building Design 2017. We are from Telkom University, Team C, and I'm gonna go to the table of contents. First is introduction, second overview, third building design and development, fourth HVAC, fifth water use, lighting, and day lighting control, sixth is cost analysis. For this year, the place taken in Gonzalo Diego Ramirez Island, Chile. The building is a single story with mezzanine office and repair building for the government meteorology employee and must approach a zero energy design efficiency. The goal for this building are meeting ASHRAE standard for 189.1 for energy performance. Second, meeting ASHRAE standard 55 and 62.1. Third, meeting local building codes. Fourth, providing a reliable and easily maintained systems. Fifth, providing an exceptional indoor environment quality, including thermal comfort, acoustical performance, as well as air quality. Sixth, maintaining a budget less than $200 per feet square. 7. Providing the lowest feasible life cycle cost for the project. 8. Sizing and designing a solar photovoltaic system for a minimum 5% of the overall building load. After studying the climate analysis, it is found that the Diego Ramirez Island has a very cold temperature, with the coldest temperature can reach minus 11 degrees Celsius on May, and with the ground temperature is 4.5 degrees Celsius classified in 8A climate zone. The relative humidity is in the range 50%, and in the night and morning, the RH reached below 47.53%. Based on the wind direction in Gonzalo, the most prominent wind originates from the west by northwest, but our building faced to south by southwest. Due to the orientation, the most efficient synergy from the energy simulation.
Site selection and layout. The site for this building is in West Gonzalo, which is a new meteorology station are planned by Chile government. The island is in Antarctica Chilena province, and total area is 1 million meter square. Basal model included 37 space with 13 space type, solar panel, equipment load, package single zone VIV, hot water system, water recycle, people definition, each schedule for every component such as number of people, people activity, equipment uses, lighting, and infiltration. Proposed model. Different proposed and baseline model is proposed using solar panel that generate energy 5% of total equipment. Changing layout have done to reduce heavy AC load. The model center activity is in the middle building to reduce heating load. Changing material of conference and bedroom to reduce noise. Changing heavy AC system to reduce loads. Exhaust system for repair building, and improving daylighting control. Building orientation. Deciding building orientation based on simulation with the standard based on climate consultant. From the graphic, the orientation is facing south by southwest. Roof plan. The roof plan was using skylight to improve daylight control and reduce the effect of environmental. Architectural design. Percentage building architectural. Type building percentage 31%, grass 18%, asphalt 25%, boundary wall 5%, paving 25%. Additionally, it is the part of the building which the building occupant will have direct interaction with and is therefore important for both energy performance as well as occupant satisfaction. Outside wall added to reduce environmental temperature. This is based on climate consultant.
For building envelope, we use exterior wall with minimum U value based on ASHRAE 90.1, table A3.1 till 3, that expect equal or less than the ASHRAE standards.
For interior construction, we reduce conference and bedroom noise by Add bed insulation a half inch and a half inch gypsum wall board to ceiling. For roof construction, based on 90.1 with value 0.2832. For fenestration, we use construction based on ASHRAE 90.1. Proposed building for exterior wall use of such material is based on the 189.1 ASHRAE standard. We have previously compared the material of the 90.1 ASHRAE standard and 189.1 ASHRAE standards, and the simulation result proved that the material of 189.1 ASHRAE standard is more energy efficient. This allows the cool air from outside the room will be easier to enter into the room. However, this can be overcome with the glazing system used because it has SHGC equal 0.309 and U factor equal 1.834, which will keep the indoor air temperature stable.
Daylight. The zone selection is based on grouping together areas with similar positioning and thermal condition. HVAC system for baseline building is based on ASHRAE 90.1 2013, table G3.1.13 baseline HVAC system types. The building baseline that we use non-residential and 3-floor or fewer and smaller than 2,300 meters square for climate zone 8 using system 3 PSZ AC PGH single zone air conditioning. Efficiency for air conditioner air cooled based on size category each thermal zone. If size category smaller than 19 kilowatt, the efficiency is 3.81 scope. If bigger than 19 kilowatt, the efficiency is 3.20x scope. Furnace specification using table 6.8.15 warm air furnace and combination warm air furnace or air conditioning unit, warm air duct furnace and unit heater. The minimum for efficiency is 80%. The exhaust system will be used in the service stall room where all the vehicle will be parked while the engine is ignited. Gases and the noise will be affected the occupant comfort so that the exhaust system will dispose the gas automatically and the indoor room will be infiltrated by the exhaust system in order to increase the comfort air zone in the room. The exhaust for V8 diesel engine will be used in this building designed to decrease the noise by controlling the noise from the vehicle straight to the exhaust system to direct the fumes away from the people inside the service stall and to increase the performance of the fuel consumption. V8 diesel engine in service stall room will exhaust the gases or any carbon monoxide to the exhaust system that is collected by exhaust manifold and will be distributed to catalytic converter. Then the noise will be reduced in muffler. The final distribution will be exhaust through the tailpipe to the outside building. Specialist HVAC considerations such as vehicle parking. Vehicle parking is space for park the workers' vehicle and use of this meteorological building due consideration the purpose of space. The space is not conditioned and due the sensible head edge vehicle. Shipping and receiving drop-off. The space is not conditioned because the purpose of the space itself. Shipping and receiving drop-off is space for goods transfer and did not need for conditioning. Service stall due the sensible load of V8 diesel engine and mechanic, the space doesn't need conditioning. Service stall used 2 days a week based on schedule. Server room due the sensible load in server room such as 4 type typical racks of blade server and 2 typical racks of networking equipment. This room does not need conditioning. For HVAC system proposed building, we have 3 alternatives. First, VRF system. The system type is VAV with reheat, then the fan control is VAV, cooling type is chilled water, and the heating type is hot water, fossil fuel boiler. Last, radiant floor heating. For the radiant floor heating, the floor using insulation are 0.62 based on 6.4.4.1.5 ASHRAE 2013 90.1. Radiant floor heating supply heat to the floor or in wall panel or ceiling of building. The HVAC system selection is VAV. Due to the total cost from the energy load, VRF energy is less from alternative choice.
The next section is the water use. This building consists of 9 surface hot water, which are placed in tech restroom areas, women toilet, men washroom, laundry, women washroom, service stall, and conference. The heater fuel type is natural gas work by the schedule for each space. The surface hot water supplied by the cold water goes to the pump. After pumping the water, it will be heated by the water heater controlled by the schedule for each space. The ground temperature is about 40 Fahrenheit degrees. Based on the weather graphic of the wet and dry bulb temperature, the water use efficiency. The next section is the water use efficiency. Measures which are being taken to reduce the overall building water use. Only the native plant will be watering regularly, which will not require permanent irrigation after being stabilized. Leak detection system. There will be a digital control system building to control the flow of matter for each toilet, washroom, and any other water using fixture, which will send the warning or alarm if the building is occupied and the flow is constantly measured. The condensate collection. Condensate and chiller will be collected in the tank storage water, which will be used for the flush toilet and some water equipment. The next section is the water conservation. In order to save as much water as possible throughout the year, the baseline will require ASHRAE Standard 189.1 2014 provide strict requirements and guidelines to ensure water is being used efficiently. The baseline design will strive to meet requirements set by ASHRAE Standard 189.1, while the final proposal will exceed the standards set by ASHRAE in order to save as much water as possible in the final design of the building. The new section and the final section is finalized energy performance, which contain the first construction and system cost, first and last year. The estimate cost of the building calculation made. The calculation item is purchase price, installation, maintenance, and life cycle. The next section is energy saving. After 50 years life cycle, total baseline cost is 3,028,622 US dollar, and the cost for proposed building with PV investor is 2,461,456 US dollar. This is mean there is cost saving amount 567,165 US dollar. In year 36, there is total cost baseline more than proposed building. It means the cost saving of proposed building happen in year 36. And for the peak load savings, for electricity, we have about 20% savings. And for the natural gas is about 36%.